There is a reason that other metal working processes compare themselves to wrought properties, that is, the properties that are produced through forging, through deformation energy. And the reason is they're trying to be as good as forgings. And of course, what I'd say is they're not going to get there because you need the deformation energy. You need the shearing forces, the strain that's produced through the deformation process in order to change the metallurgy, in order to improve it. And so those are the kinds of forces that are achieved in the forging process to really mix things together. Now, what do you get? You get improved metallurgy. That means improved fatigue properties. It means improved toughness. It means the parts are going to survive in the most severe conditions where parts made by other metalworking processes simply are not going to achieve what you need to achieve as an end result. Now, other processes that are competitive with forging, one of the things they'll do is they'll increase the alloy of the material. They'll make something out of an expensive inconel that a forging could make and provide a part in a regular steel alloy, and say, well, it's just as good. Well, you've just increased the cost dramatically. One of the things to keep in mind is, especially if you're producing in volume, if you want to use the common, less expensive structural materials for whatever component it is you're trying to make, if you go with a forging process, you're going to be able to focus on those reliable, well-known materials that have been used historically and are very successful. You won't have to go to some exotic type material to make this work using some other process. They'll say, well, we'll achieve the same thing a forging will achieve, but we have to do some additional testing. We have to do some additional heat treating. We have to do some kind of additional process, maybe hot isostatic pressing. All of those things add cost and complexity. And every time you add complexity, you add another possibility of something not being quite right. So, why would you want to use a material that you're going to have to put extra time and money into doing testing, and then take the chance that you aren't going to find the part that isn't as good? Why not just go with forging to begin with? And then you don't have to do the testing because you can rely on the process providing you what you need. So again, where do you use forgings? Anywhere you need the reliable, can't-fail part, especially when it's in a severe environment, in an environment where the part's going to be subject to great fatigue, great stresses, potential impact. All those kind of things are where forgings really have an advantage over the other metalworking processes and over many other types of material processes that aren't metal.